So good morning students. So last class we have discussed about the energies of the energy levels. Now we'll discuss about the probability of finding electron in different energy states. So we have seen in the last class. So we got k value which is equal to n pi by L, and the wave function is psi is equal to a sin kx plus b cos kx. This is equation number 5. But what is b? 0. So this is from equation 8. So what I'll do is I'll substitute 8 and I'll substitute 9 in 5. So I'll substitute 8, b 0 and k value n pi by L in equation 5. So substituting equation 8 and 9 in 5. So we'll get psi. Psi of x is equal to a sine in place of k I need to write n pi by L into x plus b cos, but b is 0. So this is 0. So I'll write this as psi nx because it varies with respect to n. Psi nx is equal to a sine n pi by L into x. Now this is equation number 11. This is equation number 11. Okay. Now I don't know the value of a. Now to evaluate a, so now I want to evaluate the value of a. So for this I'll apply normalization condition. I'll apply normalization condition. What is the normalization condition in one dimension? Integral minus infinity to infinity modulus of psi square dx is equal to 1. This is the normalization condition we know. But for this problem, what are the boundaries? What are the boundaries? It is from, boundaries are from, not from minus infinity to infinity. It is from 0 to L. Next, here this is modulus of psi n x whole square dx is equal to 1. Okay. Now we'll do the problem. Integral 0 to L. Now psi n x square, we can write it as a sine square n pi by L into x dx is equal to 1. So if we take a square, this is the constant, bring outside. So integral 0 to L sine square n pi by L into x dx is equal to 1. So implies a square. Now 0 to L. See here, how can I write sine square theta? How can I write sine square theta? So see here, I can write sine square theta as 1 minus cos 2 theta by 2. So I'll write it as integral 0 to L 1 minus cos 2 n pi by L into x divided by 2 into dx is equal to 1. So implies a square. So see here, a square by 2. This is also constant. Bring outside. Now differentiate. I mean integrate. What is the integration of 1? X minus, what is the integration of cos 2 theta? Integration of cos 2 theta is sine 2 theta divided by 2. This factor divided by this one. So cos 2 n pi by L into x. Integration is sine 2 n pi by L into x divided by 2 n pi by L. So it is from, limits are from 0 to L, which is equal to 1. So implies a square by 2. Now first if I substitute upper limit, if I substitute L minus sine, So see here in place of x, if I substitute L, in place of x, if I substitute L, see here, in place of x, this is from 0 to L. In place of x, if I substitute L here, what happens? This L get cancelled. This L get cancelled. And you are left with 2n pi. If n is 1, 2 pi, sine 2 pi. Sine 2 pi is automatically it is 0. Whether it is 2 pi, 4 pi, 1 pi or 2 pi, 3 pi, whatever it may be, sine value is 0. Okay. Next we'll substitute. So we'll be substituting lower limit minus, in place of x you substitute 0 because lower limit is 0. 0 minus, see here, minus plus sine, see here, in place of x you substitute 0, sine 0 is 0, which is equal to 1. Okay. So you got, see here, you got a square L by 2 is equal to 1. So we got a square L by 2 is equal to 1. So implies a is equal to square root of 2 by L. Square root of 2 by L. This is equation number 12. I got the value of a, root 2 by L. So substitute this a value in 11. So substituting 12 in 11, we get psi nx is equal to square root of 2 by L sine n pi by L into x. This is equation number 13. Okay. Now equation 10. What is equation 10? Energy. So energy value. Equation 10, energy value. En is equal to n square h square by 8m L square. So equation 10, energy value and equation 13. Equation 13 is wave function. This is equation 13. Wave function are called as eigenvalues and eigenvectors are called as eigenvalues and eigenvectors. Here eigenvalues and eigenvectors. So energy value is called as eigenvalue and wave function value is called as eigenvectors. Okay. Sometimes in the question they may ask. So previously there was the question. See here, what are the eigenvalues and eigenvectors for electron trapped in a one-dimensional potential box? So you need to write all these. Okay. Now see here, the probability amplitude psi and probability density, the probability amplitude and probability density modulus of psi square. So see here, the probability amplitude of psi and probability density modulus of psi square for ground state and first two excited states is shown in figure. So see here, the probability amplitude psi and probability density modulus of psi square for ground state and first two excited states is shown in the figure. So we can see in the diagram. So see here, the probability amplitude psi means psi n x. So this is from 0 to L, X. This is E1. This is energy E2, means ground state and first two excited states, E3. Otherwise we can write it as, here we can write it as n is equal to 1, n is equal to 2, n is equal to 3. This is E1, E2, E3. Next, here in the same way, this is for probability density. This is for probability density, modulus of psi n x whole square. Modulus of psi n x whole square. Next, 0 to L. This is x-axis. So n is equal to 1, ground state, n is equal to 2, and n is equal to 3. This is E1, E2, E3. Okay. Now, for n is equal to 1, this is ground state. For n is equal to 1, this is ground state from equation 10. From equation 10 and equation 13. From equation 10 and from equation 13. Okay, what is equation 10? En is equal to n square h square by 8ml square. Next, what is equation 13? Psi n x is equal to, what is equation 13? Equation 13 is psi n x is equal to a sin n pi by L into x. Okay. Now, for n is equal to 1 ground state, means you substitute n is equal to 1. We'll get it as E1 is equal to h square by 8ml square. H square by 8ml square. So, we got E1 is equal to h square by 8ml square. Okay. So, here E1 is h square by 8ml square. Here E1 is h square by 8ml square. Okay. Now, psi 1x is equal to a sin, in place of n you keep 1. So, pi by L into x. Okay. Now, sin, when it is maximum, sin is maximum at 90 degrees, pi by 2. So, here I should get pi by 2. Here I should get pi by 2. For what value of x, I will get pi by 2 here. So, at x is equal to L by 2. So, see here, if I keep x is equal to L by 2, L get cancelled, I will get pi by 2. Okay. So, at x is equal to L by 2, the probability of finding particle is maximum. So, where it is maximum, the probability of finding particle is maximum at L by 2. It is maximum at L by 2. So, this is for ground state. In the ground state, the probability of finding electron is maximum at L by 2. Next. Okay. Next. If I go for n is equal to 2. For n is equal to 2. What is n is equal to 2? First excited state. For n is equal to 2, first excited state. Now, from equations 10 and 13, means in place of n you keep 2. Here also 2 and here also 2. So, I can write it as E2 is equal to 4h square by 8 ml square, which is equal to 4 E1. E2 is equal to 4H square by 8 ml square, which is equal to 4 E1. And psi 2x is equal to root 2 by L sine 2 pi by L into x. So psi 2x is equal to root 2 by L sine 2 pi by L into x. Okay, now tell me at what value of x? At what value of x sine will be maximum? The probability of finding particle is maximum. Here I should get pi by 2. So at what value of x? At x is equal to L by 4, the probability of finding particle is maximum. So at x is equal to L by 4. L by 4. So see here it is maximum L by 4. So here psi is complex quantity. It can have both imaginary and real part. That's why curve is like this. It is going up and down. Okay, L by 4. Now here modulus of psi square only positive. Only positive. So this is L by 4. The probability of finding particle is L by 4. Okay. Now if we go for, see here, this is the probability of finding particle in first excited state. Next, if we go for n is equal to 3. N is equal to 3 is second excited state. Second excited state. So from equations 10 and 13, E3 is equal to, I can write E3 is equal to 9H square by 8 ml square, which is equal to 9 E1. Now wave function becomes psi 3x is equal to root 2 by L sine 3 pi by L into x. At what value of x the probability of finding particle is maximum? At x is equal to L by 6. Or you can write L by 2 also. See here, if I write L by 2 here, I will get 3 pi by 2. 3 pi by 2 means 270 degrees. Sine 180 plus 90 I can write. Sine 180 plus 90 is again sine 90. So I can write x is equal to L by 6 or L by 2. So at L by 6 and L by 2, the probability of finding particle is maximum. Okay. So here if I go here, okay, once you check this, the probability of finding particle is maximum at L by 6 and L by 2. If I go here, so the probability of finding particle is maximum at L by 6 and L by 2. Here also we can write it as like this, L by 6 and L by 2. Here energies are 4 E1, E2 is equal to 4 E1, E3 is equal to 9 E1. So if we see energies, it is 4 E1 and 9 E1. So this is the energies of the different energy levels. Next, these are the probabilities of finding electrons in different states. So this is about particle in potential box. So these notes will be provided in the description. Okay, thank you.